Hey everyone, so for this lesson we are looking at something called partial fraction decomposition. Now inside those words you might focus on this word decomposition, which does mean to decompose things, to break apart something. We are breaking apart a fraction into partial fractions. So this decomposition is working backwards, trying to find partial fractions that would have added together to give you a simplified fraction. So if I look at number 1, we have an overall fraction that we want to break apart into partial fractions. Those partial fractions will have distinct linear factors, and we are going to solve for the numerators needed that would have added these fractions together to give me the original fraction. So let's first look at the forward process. If I had two fractions that I was adding together, we would need a common denominator. So we start with this fraction 2 over x minus 5 plus 7 over x plus 3. When we add these together, the common denominator would be x minus 5 times x plus 3. But this first fraction needs to be multiplied by x plus 3 over x plus 3. The second fraction needs to be multiplied by x minus 5 over x minus 5. When we distribute that out, we get 2x plus 6 over that common denominator, x minus 5 times x plus 3, plus 7x minus 35 over the common denominator. Since they do have a common denominator, we can combine the numerators and simplify this down to 9x minus 29 over our common denominator, x minus 5x plus 3. Our goal is to go backwards and figure out what were the partial fractions that decomposed this original fraction. And the way that we work backwards there are actually two main ways that people can do this partial fraction decomposition. And I'll show you both ways. You can decide which way you like best. In this first example, the denominator is already factored. So when we decompose this, we can see that I would have one fraction that has some numerator with a denominator of x and another numerator that has a denominator of x plus 2. So these partial fractions are in this format. Now we need to solve for whatever a and b are that would give me this original fraction. So we're solving out that equation. I'm just going to rewrite that here for a second. And to solve a rational equation, I'm going to multiply by the common denominator. If I multiply both sides by that common denominator, it should eliminate the fractions that we're working with. All right, so when we multiply the first fraction, x minus 8 over x times x plus 2, by that common denominator, the x's divide out and the x plus 2's divide out, leaving me with just x minus 8 is equal to, if we multiply the a over x by that common denominator, x times x plus 2, the x's would divide out and leave me with a times x plus 2. Then we have the second fraction over here on the right side, b over x plus 2, and I multiply by the common denominator, x times x plus 2. The x plus 2's would divide out, leaving me with just b times x. There are two big ways that people teach and learn this concept. One of those ways is the critical value method. This is the method that I learned and I really kind of prefer, but there is another way. I'll show you that in example 2. So the critical value method lets x equal a specific number. That will help us solve for a or b. Now you'll maybe see a reason why I'm going to choose a specific value of x. So I'm going to first let x equal 0. If x is 0, then that would say 0 minus 8 equals a times 0 plus 2 plus b times 0. By letting x equal 0, I have b times 0, which is just 0. And now I have an equation that is only negative 8 equals 2a. Because b times 0 was 0, we're adding 0, but that doesn't change 2a. So if I solve for a, I get negative 4. This critical value of x equals 0 allowed me to solve for a. Now I know that a is negative 4. We could also let x equal negative 2. Now these may seem like I'm pulling these out of thin air, but there's a reason why I'm choosing x equals 0 and x equals negative 2. And we'll go through that in just a second. So if I let x equal negative 2, I have negative 2 minus 8 equals a times negative 2 plus 2 plus b times negative 2. Now negative 2 plus 2 is 0, and 0 times a is 0. So we end up with negative 10 equals negative 2b. We divide by negative 2 and get positive 5. So now I know what a and b are because we chose specific critical values of x. Now the way that I chose these x critical values is based off the denominators. I'm looking at what would have made these denominators equal to 0 because we're trying to eliminate one of these variables a and b when we're solving that equation. So now I have a partial fraction with negative 4 in the numerator over x because we had a over x plus b, which is 5, over x plus 2. If we were to add these together by getting a common denominator, we should get back to the original fraction that we started with. All right, let's look at number 2. We have negative 6 or positive 16x plus 75 over 2x squared minus 11x minus 21. So to figure out what the partial fractions would be, I first need to factor that denominator. So we're looking at 16x plus 75 on the top, but we need to factor the denominator 2x squared minus 11x minus 21. If we have been practicing our factoring skills, hopefully we're comfortable factoring this out. All right, we should end up with a 2x plus 3 and an x minus 7. Factoring that allowed me to see what the distinct linear factors will be for our partial fractions. So one of the fractions would have a denominator of 2x plus 3. Another fraction would have a denominator of x minus 7. We need to solve this equation for a and for b, and we do that by multiplying by that common denominator to eliminate all of the fractions. So 2x plus 3 times x minus 7 when we multiply this 2x plus 3 times x minus 7 times the left side, which is 16x plus 75 over the 2x plus 3 times x minus 7, we're going to see those denominators disappear because they have common factors. So I'm left with 16x plus 75. In the right side, a over 2x plus 3 multiplied by our common denominator, 2x plus 3 times x minus 7. The 2x plus 3's would divide out, leaving me with just a times x minus 7. Plus, and then the second fraction here, b over x minus 7, the x minus 7's would divide out, leaving me with just b times 2x plus 3. Now again, we're choosing critical values for x. You get to choose what values for x might be important, and so one of those values comes from the denominator 2x plus 3. 2x plus 3 would equal 0 when x is negative 3 over 2, so that's one of the critical values. If you need to use your calculator to multiply this out, that's perfectly fine, but you're doing negative 3 over 2 for every x. We're substituting that in. When we've multiplied that, let's put that in our calculator. We have 16 times negative 3 over 2 plus 75. That leaves me with 51 on the left side. Negative 3 over 2 minus 7 we can work out is negative 8.5. If it was not a terminating decimal, you'd want to use the fraction form, but you can also use the fraction form here. Plus, and then let's just double check that this will make the b disappear. That's 2 times negative 3 over 2 plus 3, and we do get 0. That's b times 0. So that b is going to disappear, leaving me with just negative 8.5a. So if I divide both sides by negative 8.5, we can do that in our calculator as well. 51 divided by negative 8.5 is negative 6. So a is negative 6. We also want to let x equal 7. All right, so let x equal 7. And I'm running out of room a little bit here, but we'd plug it in the same way. 16 times 7 plus 75 equals a times 7 minus 7 plus b times 2 times 7 plus 3. So the left side is 187 equals, and then that's going to be 7 minus 7 is 0. We have 2 times 7 is 14, plus 3 is 17, so 17b. And we would divide both sides by 17. So 187 divided by 17 is 11. b is 11. Our partial fractions in this case would say negative 6 over 2x plus 3. That was our a over 2x plus 3. Plus b, which is 11, over x minus 7. One thing you want to make sure you're doing is actually writing your final answer of the partial fractions. Just finding a and b is not the answer. That's part of what we need to put the answer together. Now, a different way to do this that's not the critical value method is using systems of equations. If I use systems of equations, we can solve using substitution or elimination like normal. So where we multiplied by that common denominator, we got an equation that did not have any denominators anymore. So 16x plus 75 equals a times x minus 7 plus b times 2x plus 3. That's what I've got here. Now what we're going to do is distribute this time. So instead of using the critical value method, I distribute the a's and get ax minus 7a, then distribute the b and get 2bx plus 3b. We can organize that a little bit, put the x stuff together. So I'm just reorganizing the right side, making that ax plus 2bx minus 7a plus 3b. Now what we have are constants and linear terms in this case. So there's a 16x that would have been equal to ax plus 2bx. There's also a positive 75 here that is equal to negative 7a plus 3b. that creates our system of equations. One of those is coming from the linear terms, this x to the first power component. So 16 is equal to the a plus 2b. That's where the x term is coming from. And then the 75 would have been the combination of negative 7a plus 3b. We've set up a system of equations, and you get to decide how you want to solve that. So you can solve by substitution or elimination. You will still get the same a and b that we found using the critical value method. Whichever way you like to do, you can. You just kind of practice both of them and see which way makes most sense to you. So we have a few more. Number 3 and number 4 are basically the same. So for number 3, if you want to go ahead and pause the video and try it on your own, you can, and then click play whenever you're ready to go back over it with me. All right, so for number 3, I first need to factor the denominator. I'm going to factor this denominator, 3x squared plus 11x minus 20. We're factoring it into 3x minus 4 and x plus 5. So that tells me that 11x plus 36 over 3x minus 4 times x plus 5 can be decomposed into a fraction of something a over 3x minus 4 plus some other fraction that is b over x plus 5. If we distribute out the common denominator, multiplying both sides by that common denominator, 3x minus 4 times x plus 5, all right, here we go. So we distribute that, it should eliminate our fractions. We end up with 11x plus 36 equals a times x plus 5 plus b times 3x minus 4. Again, I'm going to use the critical value method. So I'm going to let x equal 4/3. I chose 4/3 because I'm looking at that first denominator, 3x minus 4. That denominator would equal 0 when x is 4/3. So if I plug that in, 11 times 4/3 plus 3, or plus 36, equals a times 4/3 plus 5 plus b times 3 times 4/3 minus 4. You might want to use your calculator for these. So 11 times 4/3 plus 36 is not a terminating decimal. This is one that we're going to need to turn back into a fraction. So it's 152 over 3. And then we have a times 4/3 plus 5. So again, if you need a calculator to do that, you can. It is not a terminating decimal. It's one that needs to be turned back into a fraction. We get 19/3. Just to double check, we have 3 times 4/3 minus 4. That is equal to 0, so that's b times 0, which we don't really need to write plus 0 here. We can kind of ignore that. So I just have 19/3 times a on the right side. We would divide both sides by 19/3. If you need to put this in your calculator, you want to put parentheses around that fraction, 152 over 3, divided by the fraction 19/3, and I get 8. If you need to use the fraction button, that will organize it for you a little bit more, and you should still get 8. Now we need to find out what b is, so I'm going to let x equal -5. I'm looking at that denominator x plus 5. That would equal 0 when x is negative 5. So 11 times negative 5 plus 36 is equal to a times negative 5 plus 5 plus b times 3 times negative 5 minus 4. We plug this in. 11 times negative 5 plus 36 is negative 19. Negative 5 plus 5 is 0, so that's 0a. And 3 times negative 5 minus 4 is negative 19. So we end up with negative 19 equals negative 19b. If I divide both sides by negative 19, we get b is equal to 1. Our partial fractions would say 8 over 3x minus 4 plus 1 over x plus 5. And for number 4, again, we want to factor the denominator. This one factors out a common factor of 2x and leaves me with 2x times x minus 6. So I can decompose this fraction. All right, into some fraction a over 2x plus some fraction b over x minus 6. And again, we're doing the same process, so we're going to multiply by that common denominator, 2x times x minus 6. That would give me a equation of negative 13x plus 42 equals a times x minus 6 plus b times 2x. And again, you can still choose to do the critical value method or the systems of equations method. Whichever way you enjoy doing, go for it. I just prefer the critical value method, so I'm going to let x equal 0 for one of them. That would be negative 13 times 0 plus 42 equals a times 0 minus 6 plus b times 2 times 0. That leaves me with 42 equals negative 6a. I divide by negative 6 and get negative 7. All right, then we're going to let x equal positive 6. That's coming from this other denominator, x minus 6, so the critical value is x equals 6. Negative 13 times 6 plus 42 equals a times 6 minus 6 plus b times 2 times 6. Negative 13 times 6 plus 42 is negative 36. And 6 minus 6 is 0, so 0a, but we do get 12b. So if we divide by 12, we get negative 3 for b. That gives me the partial fractions of negative 7 over 2x plus negative 3 over x minus 6. Now you also might see that written as negative 7 over 2x minus 3 over x minus 6, just by taking that plus a negative and making it minus 3. So either answer is fine. There are two more that are considered a little bit more advanced, so I'm going to include them just for practice, but also to give you more exposure to what we could be working with, and that'll be in our second video.